Why is climate change an existential threat for Singapore? A very cheerful question for a nice sunny Monday afternoon, kind of like a Garfield day. So when I saw this question, immediately I wanted to put forth this schematic. I think the message that I want to spend about 45 minutes to an hour to expound is that we are on the cusp of something new. I think this picture kind of paints a little bit of the mindset going forward. We have a chance to turn the page from doom and gloom to a green future, actually. So what do we need to know, and what can science inform and help in this whole process? So I'm Stephen Chua. I'm a research assistant professor at NTU. I do sea level, I'm a sedimentologist, and hopefully I will be able to answer some of these questions. So when a hardworking climate scientist gets a question like this, we do what every respectable scientist do. We ask ChatGPT. So when just jokes aside. But when you put this question to ChatGPT, and I did it several times, you largely get the same answer. It seems that top of the list is rising sea levels. That means it's not just my opinions, but it's what this aggregator, intelligent as it is, seems to take from the arena and the landscape around. So it says sea level rise. Singapore is a low-level island city-state, 30% of its land lying less than 5 meters above sea level. Sea levels will continue to increase due to global warming, and then we risk coastal flooding, displaced communities, so on. Government pledged billions of dollars, and I think I have two takeaways. So number one, sea level rise is our existential threat. Okay. Number two, I still have a job. Because in my science, I'm still able to provide some of the nuances and complexities which are not really presented here. And so, as I said, I'm a geoscientist. This was me 20 years ago. This was one of the first papers I published in 2004. And I can tell you it's astonishing because I was at the forefront, literally, of the coast. This is Sungai Buloh. And you have been to Sungai Buloh? It's a mangrove area. Yeah, some hands, some knots. It has retreated at least 20 meters in the last 20 years. And I observed it. I didn't measure it, but when I went back, I was shocked. And so we continue to do science up to today. I have better instruments and better funding. And indeed, we are going to all sorts of areas to try to get this sort of geological proxies, because a lot of this sea level phenomenon is not observed, but it is recorded in our geological archives. So this is what is happening today. So I need to kind of do a shock and awe, though I'm preaching to the choir. Singapore is here. The font is not that great, but this is the temperature change from 1880 compared to today, what we call the pre-industrial. So zero, if it's white, that means no change since 1850, and you can slowly see from 1980, blue is below 1950, red is above 1950, and as you continue through the years, you end at 2020, thereabouts, and you realize that it's not a pretty picture. Right? Singapore is 1.1 degrees above pre-industrial levels. Much of the world is so hot, the Arctic is warming up to 4 times faster than the global average. Not a pretty picture, and things that we seem to know. Now, we also understand that because of this backdrop, the intensity and frequency of storms and cyclones have increased. I mean, you think about the double typhoon that went through US, Helene and Milton. You think about the horrendous floods now happening. It has occurred, but we are cleaning up in Spain. I was in Shanghai and Philippines when the typhoon swept through. I was caught up in the swells. We had to abandon our field work. So it is happening. It is happening. There's also droughts and more intense ones. So the idea of climate change is not so much the magnitude. What we cannot handle is not the magnitude. What we cannot handle is the rate of change. What we cannot handle is that a 1 in 50-year event can become a 1 in 10-year event in the coming decades. And so we have to be able to adapt to intense and frequent droughts. Dry will get drier, wet will get wetter, and then you will have heat waves. I happened to be in Europe last year during the heat wave. I experienced 47 degrees Celsius in Sicily. And this Greek wildfire threatened a lot of our historical heritage. So it's not just about industry. I think there are many domains that's going to be affected by climate change. And finally, for Singapore and for the rest of the world, sea level rise could be 1 meter by the end of the century and maybe more. So this one we seem to know, and I think these are broad statements that everybody seems to know. What does the science say? And so I want to introduce IPCC in case I believe everyone would know about IPCC, the Intergovernmental Panel on Climate Change. They published a climate report, the physical science basis. So different working groups have different reports to churn out. This one was in 2021. I'm just going to take a few snapshots. Okay, what does the scientific community say? So I need to also give an understanding for this audience. I'm going to say a statement. Okay, I'm going to say a statement. It is controversial, but hear me out. IPCC is not a scientific body. IPCC is a consensus body. In other words, it doesn't do its own scientific research. It actually canvasses. It goes around having a literature review. Of course, it has top scientists there to decide what is good, what is not. And thereafter, this literary body of work comes together in a coherent form to be communicated to governments and so on. So IPCC well-deserved the Nobel Peace Prize, well-deserved. And IPCC, over the years, you notice the tone has changed. From seeing climate change as a purely naturalistic issue, one which has to do with solar radiation, to one where he realized, sorry for the fonts, but human activities, anthropogenic causes is going to be the crux behind all that we see. And nothing can be as clear as what we call the hockey stick. So this is popularized by this scientist called Michael Mann in the US, and he actually had a paper many years ago showing this hockey stick. Basically, I was talking about rate of change. The rate of change is horrendous. It has not been seen for more than 2,000 years since the time of Christ, and it was never as warm as today was 100,000 years ago. So the question is, how do you know all this? And is it important? I'll unpack, okay? So these are two questions I want you to float around. How do we know this is true? How do we know this is not natural? And how do we know that this statement bears weight? So, one of the ways we scientists will do it is through climate models. And models are fantastic. However, models do not represent 100% of reality. And climate models, when we force it through certain physics, so these are physics-based. So we understand the processes, we know the equations, we put the forcings. So in terms of forcings will be solar and volcanic forcings. That means how much solar radiation, how much volcanic activity. And there we realize that unless there is human forcings, that means carbon dioxide being emitted through human activities, the temperature will not be so high. In other words, this is like a counterfactual. Without humans, with humans, right? Convincing? I hope that the convincing factors will be at play in COP right now, which is probably happening, started. There are 5 emission scenarios. We use SSPs now, right, from RCPs in the past. These are socioeconomic pathways that can guide society. I find it a very wonderful shift, where this is carbon dioxide emissions by gigaton based on high emission and low emission scenarios. Remember my title page? We have a chance. Our window is closing. By 2030, okay, climate is locked. It's locked. Even if everybody becomes Stone Age right now, today, carbon dioxide will continue to increase. Carbon dioxide will continue to increase, true. Temperatures will continue to increase. Sea level will continue to increase. But the trajectory after 2030 is what gives us hope. And it boils down to carbon emissions. So if we have not business as usual, but if we follow the Paris Agreement, we have a chance to bring annual emissions down. And this is what I was talking about in terms of the trajectory. Right now, the carbon scenario has been fixed and locked, but thereafter, our children and our children's children stand a chance. If what we do today make that type of goals as set up by the world. So just now, Amel was talking about this. 2023 is the warmest year on record. 2024 is probably going to break that record, and it's sad because it has been 47 years since the Earth had a cooler than average temperature. So, and all the time from 1976 all the way to today, it has been hotter. Of course, there are certain fluctuations, and fluctuations are being caught by climate skeptics. See, it's not a trend. But these fluctuations have an overall trend up till 2024 or 2020, where the current global mean temperature is at 1.45 degrees Celsius. What's the Paris Agreement target? 1.5. And actually, it was alluded to that at some point in time earlier this year, we actually broke through the 1.5 degrees Celsius globally. But why aren't climate scientists calling it quits? It's because climate is a long game. Climate depends on a 30-year average before we can say, oh, the Paris Agreement is in shambles. No, we still have a chance, because right now, if we take the 30-year running average, it's at 1.29. We have wiggle room. Let's make the most of this wiggle room. Oh, sorry. I love the US Secretary General. He has the best language, he minces no words. I wish I had a chance to meet him, because he talks about the gates to hell, and very graphic, very visceral. And I think it's needed, right? This type of language from the top person there matters. It's true, because this is indisputable. And with these trends for Singapore, coming back to Singapore, our then Prime Minister Lee Hsien Loong made this declaration. If sea levels rise by 1 meter, at the time it was 1 meter, today it's no longer 1 meter, projections. If heavy rain coincides with a high tide, so he's a very astute politician. He understands this thing called compound flooding. 1 meter doesn't sound much. It sounds like you can survive a 1 meter sea level rise, right? Up to the hip. No dice. But what you're looking at is compound flooding, when different factors come together: high tide, storm surge, heavy rain. You can have, in the worst case black swan scenario, 5 meters of sea level rise, which is why 5 meters is our magic number. So this is also what you get when you Google how can climate change affect Singapore. The PMO's NCCS, which is the National Climate Change Secretariat, this will come up first, sea level rise. And PM Lee, in the 2019 National Day rally, talks about 100 billion in 100 years. Of course, this was pre-COVID, but I think we have the political will to still make it happen, because that is what is needed. As astronomical as that amount sounds, because 30% of our island is less than 5 meters above sea level. And whenever I show this map, I'm very sure your eyes will go to your property. Where am I staying in this high and low topography map of Singapore? Well, Changi and Tuas, I don't think many people are staying there, so that should be safe. But the Kallang River Basin, now this is an area of active research, and I'm going to share you some of it. This is the most low-lying, it's almost like a floodplain delta thousands of years ago. I'll share more. And you'll notice many of the incisions along the coast, well, these are actually just river systems. Very low-lying, sometimes subsiding river systems. So this shows Singapore at threat. And I'm working with NParks a lot, and NParks always tells me one thing. Singapore has a no-retreat policy. We cannot retreat. Other countries, they have buffers. They allow the coast to go landward, retreat, go seaward. Singapore does not have this luxury, which is why we need the best science to be able to understand some of the engineering issues. So this is what I meant by Singapore's predictions has increased by more than 1 meter. It's because earlier this year, the CCRS, right, the Climate Change Research Singapore, published this third climate change study called the V3, and in it projected the worst case scenario in Shelton Shoal, where by the end of the century it will increase by 1.15 meters with huge uncertainties. The question is, are such sea level rise rates unprecedented? Because now the idea is this: we have never seen it, we don't know how to prepare for it. Or we've never seen it. How do we know what will happen, what you prescribe to be happen, will happen? But the thing is, it has happened. So I'm going to let this cartoon, okay. The little red dot is supposed to be here, okay, so it's supposed to be Singapore, as called by an Indonesian president many years ago. So I'm going to share with you that Singapore was not always an island. Singapore is not always an island. So 20,000 years ago, there's this event called the last glacial maximum. If you watch the show Ice Age, you will know what I mean. A lot of ice, very little water. And if you look at the outline here, which is going to turn yellow very soon, that was all land. In other words, you can walk to Jakarta, you can walk to Borneo, you can walk to different places, you can walk to Medan. Singapore was not an island, Singapore was a hilltop with a lot of rivers. But sea level rise up to the magnitude of 120 meters started flooding the South China Sea. And thereafter, Singapore became an island roughly about 10,000 years ago. Again, this is important because although we don't know how sea level rise will impact coasts in the future, we know how it impacted our coasts thousands of years in the past. We can use this as an example, as a comparison. Well, what caused such dramatic sea level change? So I'm going to switch to geek talk now. I'm a scientist. As I said, there are nuances that I want you to know about. And the first thing is this thing called Milankovitch cycles. Right, it's Earth Science 101. The reason why the Earth has such dramatic fluctuations in sea level and temperature is because the world receives different amounts of solar energy because of its peculiarities. It wobbles, it tilts, and most of all, this 100,000-year cycle is the distance in terms of its revolution around the sun is different along this 100,000-year-old time scale. So because of all this, it creates anomalies. So it creates this seesaw, jagged patterns of CO2, global temperature, and sea level. And you can see there's this very close relationship. It's almost unequivocal that nature has created all these fluctuations because this was all before man. But what I want to say is here, the rest, this is very scary because the world has never seen such CO2 by parts per million per volume. What is also driving many of the sea level processes is on three fronts, okay? There's the global front, there's the regional front, and then there's a local front. Globally, this is very intuitive, right? I purposely put this here. This is the Arctic, this is the Antarctic. If they melt, collectively, there's 67 meters of sea level. No more Singapore, existential threat. And the issue is just about mass balance. How much ice, how much water? You have ice melt, go into the sea, sea level rises. Very simple. As temperatures increase, we have this thing called the thermospheric effect, which expands sea level and sea level rises. Again, very intuitive. Collectively, it contributes most of the sea level rise we see today. On a regional, this is a little bit tougher to understand, but I think you can get it. Basically, sea level is not level, and that's because the Earth doesn't respond like a solid. It's actually viscoelastic. Okay? There's elasticity. So what happens if you're near here? So I was recently at the Norway-Singapore week. Norway will be sitting where it used to be ice. But the ice has melted. It has retreated. So what happened to Norway? Norway is bouncing up. So the land is going up, and therefore they don't experience the same type of sea level rise as the rest of the world. But for example, if you're somewhere near the Forebulge, you will have going up. But if you're somewhere away from it, like us in Singapore, you have a problem. Why? As ice melts, and ice is so tremendously stored in our poles, it actually has a strong attraction in terms of gravity. When this ice melts, the gravity weakens, the water is no longer pulled to the poles. Where do you think it gathers? Here. Equator, the tropics. That's why some postulations that the tropics, Singapore in particular, will have 30% more sea level rise than the rest of the world, than the global average. Simply because of this process, you're losing the gravity. Regionally, Singapore also experiences the monsoon, so the monsoon winds actually can drive sea level rise in the order of 30 centimeters because of strong winds pushing down the South China Sea. So you can see the sea level rise and sea level falling with the monsoon. That means on an annual level, we are experiencing huge fluctuations as well. This is not so much our issue, but our neighbors. Some of our neighbors, due to groundwater extraction, which I'll show another chart later, actually causes land to subside. So you must understand, sea level rise is not just sea level rise. If sea level doesn't change, but land level falls, it's sea level rise, right? Very easy. And lastly, tectonic uplift. So this one affects Sumatra more because over at the Sumatran coast, there's this huge tectonic barrier. It led to the 2004 earthquake and tsunami, and this causes land level change near this area. So all this taken together gives you all the processes that leads to something like this. As I said, sea level is not level. If there's any takeaway that you want today, sea level is not level. Tell your friends actually, sea level is not level, it's not intuitive. And as I said, Oslo, see, sea level change at high emission scenario, only 40 centimeters. Sea level change under low emissions, almost negligible. So they're not so worried about sea level rise. Somewhere in New York, further from the ice sheets, they have somewhere near the global average. In Manila, where they take extensive groundwater extraction, unfortunately, sea level can come up to 1.33 meters. So these projections were based on 2021. It may not be the most accurate today, but it drives home the fact that we must have local scale understanding of sea level research, and which is why in Singapore, that's what we try to do. So in Singapore, we have something very good. So you say you've been to Sungai Buloh, right? The most plentiful plant type in Sungai Buloh is mangroves. And mangroves are very good for sea level because mangroves can only grow in a certain tidal frame, basically the intertidal zone. In other words, if we see where mangroves were in the past, we roughly know where sea levels were in the past. And then if we combine it with some scientific techniques like radiocarbon dating, like looking at pollen to prove that that is mangrove environment. We do a host of geochemical analysis. I was able to produce Singapore's longest sea level record, going back 10,000 years. So this one was picked up by the Straits Times. It's a strategic insight, perhaps, because although, as I was sharing with you, future sea level rise rates, 5 to 10 millimeters per year, have not been observed in the instrumental era. It was observed in the early Holocene about 8 to 10,000 years ago. So we can actually have an idea. What happens to the ice sheets 8 to 10,000 years ago? What happens to sea level 8 to 10,000 years ago? What was the gradient? Was it a linear process? These are things that scientists still continue to find out. And you can see there is this very rapid sea level rise up to about 7,000 years ago. That's when the Greenland ice sheets stopped melting. Antarctica continued to melt. And in fact, Singapore, believe it or not, actually experienced up to 5 meters sea level rise in the past. So what we are afraid of today has happened in the past. So Takashimaya was actually the shoreline at one point in time. At one point in time. Scary, huh? And then sea level started to fall due to other processes driving it. So what does it mean for Singapore coast? How did we respond? You'll be pleased to know that Singapore coast did pretty well. So these are certain sediment types. So I'm a sedimentologist. I look at these sediments, and sediments basically tell you the environment, tell you the conditions, tell you the water depth, tell you the sea level conditions to allow sediments to be deposited. Let me give you an idea, okay? Let me give you an idea. How many of you have never been to the beach? Okay, good. So as you are on the sandy beach walking up, and you are barefoot, what are you first stepping on? Sand, right? Sand. As you go into the sea, what do you step on? Some sand, hopefully not a sea urchin, not a stonefish, and you continue. As you continue to go into the sea, it gets muddier and muddier. So sediments can give you an indication of the type of coastal environment. And we know the sea level changes at the time. So what can we do about it? We threw, okay, this is the main picture from it. You can take a look at the graphic, but we threw all sorts of chemical analysis to try to show what has been happening from 9,000 years to 7,000 years. So it was also picked up in newspapers. It was good. It's good publicity. So graphically, this is probably the easiest to know. So there are 3 stages. Hopefully it turns out well. So there's actually a hidden bar here that is shaded. So what it shows is that when sea levels were between 5 to 15 millimeters per year, which is going to be reached in the coming decades, sea level was so rapid that this mangrove coastline stood no chance. The mangroves couldn't stay in place and the whole system backtracked. No chance. No adaptation, no mitigation can avoid such a thing in the natural coastline. But what's interesting is that when sea levels start to stabilize at about 4 millimeters per year, which is today's global average, it stopped backtracking, retreating, and is able to accrete in place. Good news, right? And thereafter, as it continues to stabilize at about this level, the Singapore coastline at Kallang River Basin actually advanced, kind of like a natural land reclamation. So what it's trying to say is what the newspaper article talked about. The coast of Singapore is actually more resilient than other countries. We don't know why. That means if the sediments don't keep up with sea level, it is not going to retreat. It's still able to stay in place. However, it's only under natural conditions. So what are the implications for today? I think that's the question you want. This is the science. We know what happened. We know how the coastline happened under natural situations. What are the implications for today? Before that, I want to ask a question. Okay, if you know your neighbor, share this with your neighbor. What were you doing on 9th May 2013? You're on Facebook, right? Facebook Live today. What happened? For many of us, it's probably a typical day. Day at the office, day at vacation, right? But for climate, unbeknownst to us, something happened. It was the first time since 3.6 million years ago that CO2 breached the 400 parts per million by volume. First time, 2013. Okay, 3.6 million years ago. And why are we learning all this? Is because the past gives us the best analogs for near future climates. The Pliocene was here, right? That was when this paper shows that temperature was 2 to 3 degrees higher and sea level was more than 6 to question mark meters higher. So immediately you'll be asking, but that's not true, right? That's not true. This is not what we're experiencing. And that's the scary thing. It tells you that the Earth system has a feedback lag. It means that what will happen, but not yet. That means this is an expectation of the things to come until and unless we make certain changes today. And that's the scary part. Because the models that you saw never projected 6 meters. No model projects 6 meters. But the science shows that 6 meters is well possible under the same climate scenarios today. And this is what is published again in the V3 report. And you'll notice the reason why is because actually there's another band that they didn't show. It includes this instability by Mickey. So, what is Mickey? Anybody knows what's Mickey? I'm going to introduce two names to you, Mickey and Missy. Okay? And okay, I need a quick disclaimer. When people see this, they intuitively think, you scientists don't know what you're doing. Your range is so high, it's almost like you're throwing darts. Right? It's like, you're so uncertain about everything. Are you sure you know? I won't ask for a show of hands, but I think some of you probably think that way, right? Why are we so uncertain? The reason is because we are certain about our uncertainties. We understand the complexities of the system and we acknowledge all of them and we try to quantify them. But one of the unquantifiable processes right now is Mickey. And Mickey stands for marine ice cliff instability. And this is an issue because think about it, how do we monitor our ice sheets today? How do we monitor? Do we always go there? There are scientific stations there. How do we monitor? From satellites. Satellites are on top. However, a lot of the melting takes place under the ice. And so you have two processes that's being pushed about right now, Mickey, where because of this grounding line retreat, which is where the land meets the ice, it causes enough instability as it gets undercut and either the shelf collapses or it breaks apart. And this is something no model has been able to give us a good idea of what's going to happen. And it's scary. And this is related to what we call the Doomsday Glacier, called the Twitis Glacier. With the Twitis Glacier in West Antarctica breaks off, and we do not know when. That's an instantaneous 2 to 3 meters of sea level rise globally. Instantaneous, almost. I mean, when I say instantaneous, it's within boundaries. And the numbers are not great because if you look at the amount of loss from Greenland, Antarctica, Antarctica and Greenland, you'll notice that since 2002 all the way to 2020, it has lost 151 billion tons of ice. So 1 cubic ton of ice is about 1 meter square of ice. So there's 151 billion squares of these ice blocks. We have lost it, and it's not coming back. In fact, now we're talking about a ice-free Arctic summer, which has great implications for Singapore because our shipping routes could be such that it goes up to the polar caps and come down, and it skips us totally. So at this moment, can I just take a poll? How do you feel right now? It's not. Can you help me skip it? It's not moving. There's hope. I really just want to say that there's hope. And I go back to my hero, the US Secretary General Antonio Guterres. He says that he talks about highway of hell, right? Highway to climate hell. But the truth is, we have control of the wheel. And I think I leave it to my colleagues who are better positioned to make this thing about what the world is doing in terms of regulations, laws, and so on. In Singapore, I think I'm very proud that we have a whole of society approach where we look at engaging the public sector, private sector, and the individuals. And indeed, the rest of these days, I'm looking forward to some interesting conversations that will take place in terms of the net zero plan in the Singapore Green Plan. Now, cutting edge science. So what can scientists do in the midst of all this? As I was saying, right, Singapore has a no retreat policy. And Singapore also has a 30 by 30 framework. In other words, 30% of Singapore must remain natural by 2030. So what are these places that has to remain natural? Our wetlands. So much of Sungai Buloh and Mandai mudflats will be conserved. But the problem is, do we know how sustainable they are? The only way is to understand the dynamics. So for example, mangrove forests can actually keep pace with sea level rise up to a certain degree. It will keep pace because sediments get trapped and is able to keep up without going backwards. However, we realize that 7 millimeters per year is the global average beyond which the system tips, that's the tipping point, and the whole mangrove forest will go backwards. Now, what is here? What is behind the mangroves? Urban development. Our mangroves will get squeezed, they will not survive, and we lose it. Once you lose it, you lose it. That's the definition of a tipping point. So in EOS, at the Earth Observatory of Singapore, we have a project looking at the mangrove accretion rate, the carbon rate. So mangroves are a fantastic carbon stock. We also want to quantify the amount of carbon in these systems, and we want to actually identify and determine what is our Singapore mangrove tipping point. Right? So this is a project that we have. We also go to Antarctica. So this is a picture of my director, Professor Ben Horton. This is a homegrown Singapore PhD student, now a research fellow, Tan Fang Yi. And we send them to Antarctica. And a lot of people on the YouTube comments say, why is Singapore spending that money to send people to Antarctica? Don't we have enough problems here? But you realize one thing. Sea level rise is a global problem. We must understand what's happening in the poles. And so we went there, we conducted some simple scientific analysis, and then we kind of did a documentary, which is being shown, I believe, in YouTube and different parts and on different avenues. So if you're interested, please take a QR code. Okay, that looks strange. Okay, so stakeholder public communication, almost to the end already. I believe it is imperative that scientists do a better job communicating. I was talking to Amel just now. I was asking, is there a translation gap? Is what scientists say kind of give policy makers room to doubt? It's like we cannot pinpoint a lot of things. Are we trustworthy? And I think scientists have a responsibility to do a better job. So a lot of things we do is, for example, we'll talk to the media, and then we try to bring our science above, beyond the ivory tower of universities. This is about Long Island. So Singapore is conducting a Long Island analysis, and these are the barrier islands that Singapore will be building. So EOS is talking to PUB, EOS is talking to HDB right now to try to better understand this system so that we can prepare Long Island for a sustainable future. And so this one is also a podcast that was on CNA, and that's where we try to bring and communicate science to the masses. Lastly, last slide, the climate transformation program. So this is something that I think we are aware of, whole of society. So in this case, we have 6 pillars that we want to continue to bring our science out into the public good. So in terms of processes, biodiversity, mitigation, climate engineering, climate finance, climate and health. I think what we are trying to do is not just produce lots of papers, right, and get promoted to tenure. What we are trying to do is really to make sure the science make a difference. We really need this to go out there. So we're working with different colleagues in and around NTU to have a holistic approach using AI, using stakeholder community, and using remote sensing to be able to push climate transformation into the future. And so, just in conclusion, I think suffice to say, climate change-induced sea level rise is an existential threat to Singapore and other coastal populations around the world. Future sea level rise rates are unprecedented. We have not seen it in the modern era, but it's occurred in the distant past, and we can learn from that distant past. Understanding this change and coastal responses provides key information for mitigation and adaptation measures. And finally, I think there remains hope. When all sectors in society work together, in the room, and Baku, work together against this existential threat to humanity. And with that, I thank you.